Okay, this is calculus 1.3 over here. Very easy. It's about continuity and it's very easy. Okay, let's just chop. Okay, select the intervals where the intermediate value theorem guarantees a root of x cubed plus 4x minus 8 is contained. So what is the intermediate value theorem? It's very easy. Okay, basically it's a rule that says, okay, let me draw the function for you. I'm going to draw any function. It's a rule that says, okay, if there's a graph over here, it's continuous. يعني it continues. It doesn't stop like this. No, it's not. It's continuous. If you have a continuous function and there is a value of the function at which the function is negative and the value of the function at which the function is positive, then somewhere in between these two values there exists a root where f of x is equal to 0. What does that mean? Yani over here, let's say the interval, let's take -3 and I don't know, 5. Let's say over here at 5 the value of the function is 1, and at -3 the value of the function is about -1 also. So you have -3, -1, and you have 5, 1. So going from -3 to 5, your y value went from -1 to 1. The whole point of this theorem is to say that there exists a root. What does root mean? Root means f of x is equal to 0. So don't you think going from -1 to 1, you're crossing 0 somewhere? Yes. So this is actually a very important rule in math, and it helps mathematicians look at graphs and identify when you have a root. Okay, so the whole rule is, here you can make a conclusion that there exists a root. There is a root. There exists a root for x in between 5 and -3. How do we know? Since it changed from negative to positive. So how do we solve this here? You have to check each one. You have to check each one and check if it changes from negative to positive. So let's substitute -1 into x cubed plus 4x minus 8. -1 cubed plus 4 times -1 and then minus 8. You get -13. So here it's negative. Now let's check 0. 0, it will also be negative. Since it's negative, if you're staying in the negatives, what does that mean? Did you cross the 0? No, you're still in the negatives. So that means there is no root. Okay, let's try 0. 0, we said it's negative. When you substitute 0, you get a negative value. When you substitute 1, what do you get when you substitute 1? You get 1 plus 4 minus 8. You get negative as well. So since it's negative again, that means it doesn't cross the 0. So it's no root. Now once you try 1, you get negative, as we said before. When you try 2, you should get a positive root. Let's add a positive value. 2 cubed plus 4 times 2 minus 8. You get 8, which is positive. So since you went negative to positive, that means you crossed the 0. You crossed and there exists a root. Okay? Again and again, -1, we said it's negative. We said it up here. And 2, we just found it. It's positive. So again, since you're crossing, there's a root. 0, we said it's negative. And 2, we said it's positive. So again, there's a root. Okay, in between these two x values. Okay, moving on. Question 2. Consider a function f defined by f of x is equal to this piecewise. Over what interval is f continuous? So let's try and remember from 1.2. When is a piecewise function continuous? It's continuous if the limit as x approaches a minus is equal to limit as x approaches a plus. This is if it's continuous, right? So let's take a look here. Let's try -1, 0. Let's try here. Limit as x approaches -1 minus. Now see, there's nothing before, so we're just gonna substitute -1 and see. Okay, no, this is the lower bound. It doesn't really matter. Okay, and as you can see, most of the options contain -1. And no, خلاص, since it's the lower bound, there's no function before it to try -1 minus. Yeah, so let's just substitute عادي. -1 squared plus 1, you get 0. Okay, so you have 0. Now let's look at the other bound. You have 0. Okay, so now let's check the limit as x approaches 0. We have what? We have 2 times where we see 0. Remember, we have to check 0 minus and 0 plus. Which one would be 0 minus? The one before, right? So which one are we going to check 0 minus? Here. So let's check 0 minus. It's going to be 0 plus 1, which is 1. Now let's check 0 plus. When we check 0 plus, what does that mean? We're substituting into what function? You're substituting into this. So 1 minus 0, which is also 1. As you can see, the limit of 0 minus is 1, and the limit of 0 plus is also 1. So what does that mean? It's continuous. Okay, so until now, we're continuous from negative 1, 0. Okay, let's check the next bounds that we have. Let's check 1, مثلا. Let's check 1. Okay, so now let's check the limit as x approaches 1. Remember, we have to check 1 minus, and we have to check 1 plus. Okay, so 1 minus, what do? You substitute into which one? This one here or this one? Obviously the one before, right? We're going to substitute 1 minus. That means you want to go to the function before. So 1 minus 1 equals 0. How about 1 plus? Now we substitute 1 into which one? Here. So 1 minus 2 squared equals negative 1. As you can see, here it's 0, here it's negative 1. Are they equal? No. Okay, so does that mean it's continuous at 1? No. So it's not continuous. So until now, we got it's continuous from negative 1. We went to 0, it's continuous, but 1, it's not continuous. So that means it's only continuous from negative 1 until 0. Okay, that's it. You just have to check the bounds. Now, someone's going to ask me, Walid, why didn't you check 2? Again, the same reason I didn't check. You don't need to check negative 1. You don't have to check 2 because negative 1 is at the lower bound. There's nothing before it. 2 is at the upper bound. There's nothing after it. Okay, so we don't really care. We just care about what's in the middle. So the 0 and the 1. Okay. Question 3. Consider the following graph of the function g. Which of the following is true? Okay, we have something called left continuous and right continuous. And from the name, basically, left continuous means that the limit as x approaches a minus is equal to the limit as x approaches a. This is left continuous. And then right continuous, limit as x approaches a plus should be equal to the limit as x approaches a. Okay, this is the rule. Limit as left and right continuous. So let's take a look. G of x is left continuous at x equals 1. From the graph, at x equals 1, when we say left continuous, that means we want to look at as x approaches 1 minus, it should be equal to as x approaches 1. So as x approaches 1 minus, as you can see here, what are the values of the function approaching? They're approaching 3, right? Over here. And at 1, how much is the function? It's also 3. So, that's correct. Now let's take a look at right continuous at x equals 0. So, at x equals 0, what do we have? When we say right continuous, that means we want to look at x equals 0 plus and x equals 0, right? So, at x equals 0, the function of the function, remember, just so you guys know, by the way, when we say, you see how there's a shaded circle and an open circle? The open circle, because you're going to see 2 points sometimes, you're going to be like, oh, which one do I choose? The open circle means you don't choose it, okay? That means it's not part of the graph. It's undefined at that point, okay? So, which point do I take here at 0? I'm going to take the shaded one. How much is it at 0? It's 3. Okay, so how about 0 plus? Let's take a look. To the right of 0, what's my function approaching? To the right of 0. To the right of 0, my function is close to what? 2, right? So, are these two equal? They're not equal. So is this right continuous? No. Left continuous at x equals 0. Again, let's take a look. At x equals 0, sorry, when we say left continuous, what does that mean? We're looking at 0 minus and 0. Yalla, at 0 minus, to the left of 0. If I look to the left of 0, what is my function going towards? 3, right? So 3. How about at 0? At 0 itself, we actually said it in the previous part B. At 0 itself, like we said, there's 2 points. Which ones do we take? We take only the shaded one. Sometimes they might not put a shaded one, by the way. They will only put a open circle like this. But they don't put a shaded one. You're going to see this sometimes. Same thing. You always ignore the open circle. Always. Okay? You take the one that isn't an open circle. Okay? So over here, at x equals 0, which point do we take? 3. Okay? So 3 and 3, are they equal? Yes. So that means it is left continuous at x equals 0. G of x is continuous at x equals 0. Now here they didn't say right continuous, they didn't say left continuous, they just said continuous. When you say just continuous, that means a plus equals a minus equals, a plus equals a minus, that's it. Okay, that's all you need to know. 5. Let's take a look. That means, what's at 8 plus? To the right of 0 over here, to the right of 0, what are we approaching? 2. To the left of 0 now, a minus, what are we approaching? 3. Are they equal? No. So it is not continuous at x equals 0. G of x is continuous at x equals 1. Let's take a look. At x equals 1. Over here. To the left of 1, we're still approaching 3. To the right of 1, we're still approaching 3. There's no change in the graph. It's still the same line. Okay, so for that reason, since it's 3 and 3, for 1 plus and 1 minus, that means it is continuous at x equals 1. These questions, explaining them takes time, but doing them in the exam will not take you time. Okay, you need to be quick with it. Okay. The graph of a function r is shown below. Which of the following is true? Type r of x is right continuous at x equals 2. Same thing. Okay, I'm gonna go a bit faster. Right continuous. What does that mean? We look at what's on the right of it. We look at 2 plus and 2 normally. So let's see. At x equals 2. To the right of 2, what value of x are we approaching? 1. Type at 2 itself. Let's go to the graph at 2 itself. Sorry. At 2 itself. We check 2 plus and we got 1. Now at 2 itself, we have 2 points on the graph. Which one do we take? Do we take the open circle? Never. Right? We only take the shaded circle. And what's the shaded circle? 1. Are they equal? Yes. So it's right continuous. Yalla, left continuous at x equals 2. Let's take a look. At x equals 2, left continuous. What does that mean? We look at 2 minus and 2 plus. And 2 normal. Okay? 2 minus. To the left of 2. Where's my graph? To the left of 2, it's over here. What value is it approaching? 4. Okay, so we have 4. How about at 2 itself? At 2 itself, like we said, we have 2 points. We have the open circle and we have the shaded circle. Which one do you choose? You never choose the open circle. You take the shaded circle. So at 2 itself, how much is the graph? 1. So I have 4 and I have 1. Are they the same? No. Okay. Is right continuous at x equals 0? Let's take a look. X equals 0. When we say right continuous, what do we look at? We look at 0 plus and 0. Yeah. At x equals 0, look at 0 plus. Yeah? Look at 0 plus. To the right of 0, what value is it approaching? Approximately 5. Let's just say 5. Okay? At 0 itself, go to the graph at 0. What value is it? It is that same point, approximately 5. Are they the same? Yes. When it's obvious that the graph doesn't change, when it's a straight line or it's a curve that continues, it's obvious that it's continuous. Just choose it. No need to go through all this hassle. You know what I mean? R of x is continuous at x equals 2. When we say continuous without left, without right, what does that mean? That means 2 plus will be equal to 2 minus. Let's take a look. Is that the case here? 2 plus, so here we have 2. When I go to the right of 2, I'm on this graph. And what am I following? What am I approaching? I'm approaching 1. How about 2 minus? When I go to the left of 2, I'm approaching here this value over here, which is 4. So I have 1 and 4. Are they the same? Of course not. R of x is continuous at x equals 0. Like I said, when it's obvious, خلاص, at x equals 0, look at x equals 0. When you go to the left, you're still on the same curve. When you go to the right, you're still on the same curve. Without looking at numbers, without looking at all that, it's very obvious it's continuous. You don't need to waste your time. But for the sake of explaining, I'm going to show you. Okay, when we say it's continuous at x equals 0, that means 0 minus and 0 plus should be the same. Go to the left of 0. What are you approaching? You're approaching this 5 over here. And go to the right of 0. What are you approaching? You're approaching that 5 as well. Okay, so that means it is correct. Question 5. Consider the function whose graph is true shown below. So we have this over here. I think you guys can see the open circles. Yeah, you have this open circle, this open circle, this open circle. So basically means at that point it's undefined, right? So let's take a look at what are they asking. What are they asking us here? Over here, limit as x approaches negative 2 is 2. So let's take a look at negative 2. What is the limit? Is 2, not negative 2. What is the limit as x approaches negative 2? Now, someone will tell me, okay, what he told me, open circle is not included. So which point do I take at negative 2? I take this one, and it's 2. He's going to put it, he's going to check his mark after the exam, he's going to get it wrong. Why is it wrong? Let's take a look here. What is the case for a limit to exist? What's the case? What's the case for a limit to exist? Remember from 1.2, for a limit at any a to exist, that means the limit at x approaches a minus should be equal to the limit as x approaches a plus. In other words, it has to be a continuous function. Now, the second you see a shaded circle and an open circle, that tells you one thing and one thing only, that it's a discontinuous function. So, for that reason, like I said, I cut off. But for that reason, since it tells you that it's not continuous, what does that mean? Does this limit exist? No. Now, and see, the part B follows it as well, right? Does it exist? It does not exist. Okay, f is not defined at x equals 1. Let's go to x equals 1 and look at, is it defined? So our function f, when we say it's not defined at x equals 1, that means there's an open circle. Okay, now someone's gonna come and ask me, okay, Walid, there is an open circle. Why is this option not chosen? Because although there is an open circle, there is a point above it where it's shaded. But if it comes to the case where you have an open circle, وخلاص there's no shaded circle anywhere else, then you can say that it's not defined. Okay, but since there's a shaded circle up, that makes up for the open circle. F is continuous at x equals -2. Take a look at -2. Since, even if you don't have a graph, if I went and told you that the limit at x equals -2 doesn't exist, that means you will immediately say that it's not continuous, okay? مجرد ما انت you said this, that it does not exist, you can conclude that it's not continuous at -2. But we have a graph, so let's use it. Look at -2. Is it continuous? As you can see here, it jumps from here to here, right? You have a jump. So it's obviously not continuous. And that's the option here. So the last one, the limit as x approaches 2 minus, -2 minus, and -2 plus are not equal. This is the symbol for not equal. If you can see it, there's a dash that goes through the symbol. Okay, are they not equal? Of course they're not equal. How do you know they're not equal? Well, obviously you can look at -2 minus, look where it is, it's at 2. And at -2 plus, as you can see, it's on the right curve, it approaches 1. So are these two equal? Obviously not. Okay, question 6. Okay, consider the function f given by f of x is equal to this for x does not equal 9 and x greater than 0. If the function f is continuous at x equals 9 and f of 9 is equal to k, what is the value of k? So, when we say it is continuous at x equals 9, that means what? What does that mean? It means the limit... wait, what? Yeah, it means that the limit as x approaches 9 exists, right? So, when you go and substitute 9, you can see that 9 squared minus 8 times 9 minus 9 over 6 root 9 minus 18 is 0 over 0. Okay, there you go, right? You're gonna see like, oh wait, what do I do? Okay, so you gotta fix up. So obviously, since we know that it exists and we got 0 over 0, we gotta do something about it, right? So what do we do now? People do factoring, and honestly, I extremely dislike it. Every math teacher is against factoring. Nobody would prefer factoring. Okay, if you were taught it, throw it out the window and learn L'Hopital. You need L'Hopital. Okay, what's L'Hopital's rule? L'Hopital's rule is if the limit as x approaches a of any function f of x over g of x equals 0 over 0, then the limit as x approaches that a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. In other words, if you get 0 over 0, take your numerator, derive it, get the prime, let's call it u prime. Okay, take the denominator, derive it, let's call it v prime. You get a new function now called u prime over v prime, and substitute that same limit into it. I explained this in the 1.2 video, so I'm not gonna talk a lot about it, okay? So, yalla, let's go. Let's derive now our numerator. X squared minus 8x minus 9. What is it? It becomes what? 2x minus 8, right? And 6 root x minus 18 becomes what? 6 over 2 root x, I think. Right, let's... what's the derivative of root x? The derivative of root x is... because, you know, root x is the same as x to the power of 1 over 2. Multiply, you're going to get 1 over 2x. Subtract the power, you get negative 1 over 2. Yeah, so it's 1 over 2 root x. Okay, so you can't forget the 6. So 6 over 2 root x. Okay, so that is your new function. You can cancel the 6 and 2, it becomes 3 over root x. Okay, so your new function is 2x minus 8 over 3 over root x. Substitute your bounds one more time. You're gonna get 2 times 9 minus 8 over 3 over root 9. And you're gonna get 18 minus 8 is 10 over 3 over root 9, which is 3, which cancels, and you're gonna get 10. You can do all this in the calculator, no need to write it down. Okay, but you get 10. Okay, what is the key step here? L'hôpital. Okay, l'hôpital.
Please, when I say
Question 7.
hit it.
Consider the function 3 sine squared x minus 4 plus 12 if x is less than or equal to 4, and kx squared minus 148 if x is greater than 4. What is the value of k if the function is continuous at x equals 4? What does this mean when a function is continuous in a piecewise? Piecewise is when you have before and after, yeah? When we say it's continuous, that means the limit as x approaches 4 exists. Yeah, it exists. And what does that mean if the limit as x approaches 4 exists? It means that the limit as x approaches 4 minus is equal to the limit as x approaches 4 plus. So over here, we gotta find the limit as x approaches 4 minus and find the limit as it approaches 4 plus. So when it approaches 4 minus, you're gonna get 3 sine squared 4 minus 4 plus 12. And this is all 0. And so you get 12. Okay? Now, as x approaches 4 plus, that means substitute 4 into the 1 down. So k into 4 squared minus 148. So you're going to get 16k minus 148. So, now that it's continuous, we agreed it's continuous. So what does that mean? That means the limit of 4 minus is equal to 4 plus. So 16k minus 148 is equal to 12. For 16k is equal to 160. For k is equal to what? 10. Very easy. Okay, question 8. Which of the following is true? Select 2 options. Okay, you have another graph. As you can see, you have open circles, shaded circles, so some minor details that you should pay attention to. H is not continuous at x equals negative 1 because its limit at x equals negative 1 does not exist. So let's take a look at negative 1. H is not continuous at negative 1 because its limit does not exist. Okay, for part A, I look at ChatGPT this. It's not continuous because the limit does not exist. Now, here, obviously it's not continuous. As you can see, it goes, it opens, and it jumps up, then comes back down. So it's obviously not continuous. But is it correct to say that it's not continuous because the limit does not exist? No, that's wrong. Because the limit exists. What is the rule for a limit to exist? For a limit to exist, what's the rule? The only thing you need to know is that a minus should be equal to a plus. And as you can see here, to the left of it, you're approaching this, you could say 1.5. And to the right of it, you're also approaching 1.5. So the limit exists. But the reason that it's not continuous is because it's undefined at that point. Okay? So if they said because it's undefined at that point, as you can see here, negative 1. No, it's not undefined. How can I say it? Is I'm trying to think of a reason. You could just say because the value of the function is different from the value of 1 minus negative 1 minus and negative 1 plus. Okay, just no عادي. And if they ask for a but they're never gonna ask for a justification. But my whole point is it's not because the limit does not exist. The limit exists, but you just jumped up. Okay, so the value of the function at that point is different than that of the limit. Anyways. Oh yeah, you could say, yeah, since f of negative 1, which is the value of the function of negative 1, which is 2, it's not equal to the limit as x approaches negative 1. Okay, it's not equal, because the limit as x approaches negative 1 is like 1.5. It's this point here. Okay, anyways, let's move on. Part B. So this is first one we agreed it's wrong. H is not continuous at x equals 2 because it's not defined there. As you can see, at x equals 2, it's not defined. Now, someone's going to say, Tabir, Walid, it's an open circle. Why didn't you say it's not defined? Because there's a shaded circle. Here, there's no shaded circle to make up for this open circle. Okay, so you can just, it's can know the graph reached this point. At this point here, it was like, no. I'm not going to continue. It jumped and went down. Okay, so it kind of skipped. That's what the open circle means. Okay, you kind of like, it has a hole, you know. So it's not defined there. Yeah. H is continuous at x equals -2. At -2, as you can see here, it's continuous. Look, if you want, yani, without looking at the limit, just look. You're going and you just continue, bro. You know, there isn't any open circle. There isn't any change. It's not like this and then goes up and there's like this gap. There's no gap, as you can see. It's just continuing. Okay. If you want to say it in terms of limits, at -2 minus to the left, you're approaching still what? 1. And at -2 plus, you're still approaching what? 1. Same point. Okay? طيب. H is continuous at x equals -1. At x equals -1, is it continuous? No, obviously it's not continuous. We said why. Why? Is it because the limit does not exist? No, the limit exists, but why? It's because the value of the function is different than the value of the limit. Okay? So it's not continuous. It's not continuous at x equals -1 because it's not defined there. Like we said, the reason for it not being continuous is not because it's not defined. It's not because the limit does not exist. It's because the value of the function is different than the value of the limit. The value of the limit is down here. Okay? Don't say it's undefined. It's definitely defined. Why would you say it's undefined if the point is right there? It's shaded. It's right there. There's no reason for you to say it's undefined. Okay? Question 9. At what value of x is g of x discontinuous? So I guess you have to try every single one. So اتفقنا to do it, to check if it's discontinuous, you have to check the limit at a minus and a plus and see if there's the same. So let's start. Remember we said we're not going to start never mind. We're going to start yellow from 1. Let's start from 1. At 1, let's evaluate the limit as x approaches 1 minus, and I'm just going to write 1 plus. It's too much writing. Okay, at 1 minus, that means you're substituting 1 into here. And here the function is always 2. So no matter what you do, it's always 2. It's just 2. Now 1 plus, so you substitute 1 into the next function. So 2 times 1, which is also 2. So the limit as x approaches 1 exists, and it is continuous. طيب, let's continue. Over here, let's try 2 now. Let's check 2 minus and 2 plus. Lim. Okay. 2 minus, that means you substitute 2 into here. So 2 times 2, which is 4. And then you substitute 2 into here. So -2 plus 6, which is also 4. So it exists. It's continuous. Now limit at 3 minus and 3 plus. Okay. At 3 minus, substitute 3 here. -3 plus 6 is what? 3. 3 plus, you substitute here. 3 plus 3, 6. Are they equal? No. So when is it discontinuous? 3. Okay. This is the next day. I'll pause the recording because I got tired صراحة. المهم بس question 10. Consider the function g of x and it's a piecewise. You have the first function sine 12x over 3x, and then the second function is just b. Okay, b يعني is a number. Okay, b is a whole number. The conditions x is when this is the function when x is not 0, and this is the function at x equals 0. So what is the value of b that makes g of x continuous over the set of real numbers? What does it mean when it's continuous? That means the limit here should be equal, the limit at x equals 0 of, let's call this f of x, should be equal to the limit at x approaches 0 of b, right? Remember, for it to be continuous, that means they should be approaching the same number at 0. Okay? Anyways, let's do this. Again, once continuous is the rule. The limit here should be equal to the limit here. So let's continue now. What's the limit of this one as x approaches 0? So the limit as x approaches 0 of sine 12x over 3x, what's it equal to? Remember the rule for this type of limit, sine ax over b as x approaches 0 is what? It's equal to a over b, right? So over here, the limit is just going to be equal to 12 over 3, which is 4. And then limit as x approaches 0 of b is just b, right? Of any constant number, it's always just that, the constant. So our rule is that the limit here should be equal, f of x, should be equal to the limit of b. The limit of f of x is 4. The limit of b is just b. So what does that mean b is? B is 4. Okay, moving on. Question 11. Same thing, consider the function f of x equals x squared minus 36 over x minus 6, and then m. So this is function and this function. Same exact thing, they're saying for it to be continuous. What's the rule? That means the limit of f of x, let's just call the first function, g of x, because they called the whole thing f of x. So I'll just call this one here g of x. Limit of g of x as x approaches what number here? 6 should be equal to the limit of m as x approaches 6, right? So let's see what's the limit as x approaches 6 here. If you do 6 squared minus 36 over 6 minus 6, you're going to get 0 over 0, which is indeterminate form. Put IDF, okay, in your exam, if you get something like this. Then we know that no limit exists at 0 over 0. So what do we have to use? We have to use L'Hopital, right? So let's take our numerator, x squared minus 36, and our denominator, x minus 6. Let's derive them. X squared becomes 2x, 36 doesn't get derived, x minus 6 becomes 1. So our new function will become 2x over 1, which is just 2x. Now, substitute in our limit again. What's our limit? Limit as x approaches what? 6. Substituting x as 6, 2 times 6, which is 12. Okay, so the limit of g of x as x approaches 6 is what? 12. What's the limit of m as x approaches 6? Since m is just a whole number, that means it's just going to be equal to m. So 12 is equal to m. Question 12. Given the function f of x is absolute value of x plus 2, if any of the limits slash values do not exist, enter 999 for your answer. So the limit as x approaches 2 minus. Let's take a look. Yeah, let's just do it. This shouldn't be that hard. So let's do, as x approaches 2 minus, substitute x as 2, 2 plus 2. Whoa, how is it 0? I'm sorry, I didn't see it. That's not a 2, that's a negative 2 right there. Okay, so negative 2 plus 2, which is what? 0. And then negative 2 plus, again, same thing, negative 2 plus 2, which is 0. And then negative 2, same thing, negative 2 plus 2, which is 0. And then f of negative 2, which is negative 2 plus 2, which is 0. So all of these are 0. Okay, and since the limit, since the limit is equal to the value of the function at that x point, they're both 0, then f is continuous, right? What's the rule for it to be continuous? The rule is, for continuous, that at 2 minus, it should be equal to 2 plus. Also, you could say that the limit is equal to the value at that x coordinate, okay? These are all ways you can tell if it's continuous or not, okay? And I think if you get 0 for everything, it sort of gives you a hint that it's continuous, you know? 13, consider the function 4x and then x squared plus 4. The continuity point is 2 here. So same thing, let's do as x approaches 2 minus, what is the limit, and so on and so forth. Let's start. As x approaches 2 minus, that means do I substitute 2 into the first function or the second function? If I'm approaching it 2 minus, that means I approach it into the one from the left, right? So we're going to start with 4x, so 4 times 2, which is 8. Then 2 plus, that means I substitute 2 into where? I substitute 2 into the second function, the one on the right. So 2 squared plus 4, which is also 8. Okay, and then the limit as x approaches 2. Remember, for a piecewise function, for the limit to exist, that means the limit at 2 minus must be equal to the limit at what? 2 plus. Are they equal? Yes. Since they're equal, that means the limit is 8. Okay, now, if you got, for example, 8 here and then 6 here, that means here, what do you put as your answer? You put 999. Why would you put 999? Because if you got 8 here and 6 here, that means the limit at 2 minus, the left limit and the right limit are not equal. And when the left and right limit are not equal, that means the limit aslan does not exist. Okay, so in this case, they are equal, so it does exist. So 8, 8, 8, and therefore, if you substitute f of 2, the function, you should also get 8. Now, someone might tell me, okay, which one do I substitute 2 in? Someone might tell me, which one do I substitute 2 in? Over here, you substitute it into the first one, okay? Regardless, مثلا, if, my point here is, what if they didn't give you part A? They didn't give you any of this, okay? What if they just gave you what's f of 2? Okay, what's f of 2? How would you tell over here? F of 2 over here, you'd ask yourself, do I substitute it into this one or this one? Look at the domain, right? We want it at 2. Here, it's all values greater than 2. Here it's all values less than or equal to 2. And I want to see when is it equal to 2? Only here. Here it's not equal to 2. It's strictly greater than. Okay, so I don't substitute it into here. I substitute 2 into here. So 4 into 2, which is 8. In this case, it's all the same thing. But you may get a question where it's not the same thing. Okay, so 8, 8, 8. And obviously, what does that tell you? That it's continuous. Okay, question 14. Consider the function 2x plus 1, x plus 2. As you can see here, which of the following statements is true? The limit as x approaches 0 minus is equal to f of 0. طيب, as x approaches 0 minus, that means do I substitute 0 into the right one or left one? Obviously the left one, right? So 2 into 0 plus 1, which is what? 1, right? So we got 1. What is f of 0? Now here's the same thing, and this is what I said earlier. You need to know where do you substitute the 0 in. Some people might substitute 0 into this one, get 2 times 0 plus 1, which is 1, and say, oh, they're equal, so this is true, and they select it, and they get it wrong. Now, why is that wrong? Like I just explained in the previous question, you need to substitute 0 into when is the function equal to 0? When is the x value 0? Is it equal to 0 here? No, here it's all values. They're all strictly less than 0. They're less than 0, right? So here, they're greater than or equal to 0. So you have to know which one you can substitute into. So you have to substitute the 0 in this case into here. 0 plus 2, which is 2. Again, why? Because here it's not equal to 0. It's all values strictly less than 0. Here it's greater than or equal to 0. Now, as you can see, you got 2, here you got 1. Are they equal? No, they're not. Limit of f of x as x approaches 0 plus is equal to f of 0. I'm just going to call this f of 0 because we may need it for the rest of the parts. Okay, 0 plus. So do I substitute 0 into the left function or the right function? Obviously, the right function, right? So 0 plus 2, which is 2. And as you can see, they are equal. F is right continuous at x equals 0. F is left continuous at x equals 0. F is continuous. Okay. What is the definition of right continuous and left continuous? To be right continuous, that means on that point, you continue to the right and it continues. Now, over here, mathematically, the definition of that would be that f of whatever, 0, should be equal to, since we're talking to the right continuous, limit as x approaches 0 plus of f of x. Okay, this is the definition of right continuous. If it was left continuous, that means f of 0, when you go left, so that means you approach 0 minus. This is right continuous. This is left continuous. Okay, this is the difference between. What does this mean? It means at 0, you go to the right, they should be equal. Here it means at 0, we're going to the minus, to the left, and they're equal. Okay, this is the difference between these two definitions. Okay, anyways, that being said, let's solve. If we're saying right continuous, that means f of 0 should be equal to going to the right, yeah? What is f of 0? To find f of 0 is 2. What is the limit of 0 plus? 0 plus, that means you're going to the right. So which one is it? It's this one. So what? No, it's this one over here. I found it, right? Going into the right, I substitute 0 into this function. We already did it in the previous part. We found it to be 2. Since they're equal, you can deduce that it is right continuous. Now, for it to be left continuous, that means f of 0 should be equal to limit as you go to the left, so 0 minus. Now, we found the limit of 0 minus to be 1. We know that f of 0 is 2. Since they're not equal, it's not left continuous. Is it continuous at x equals 0? When you just say continuous, that means it's both right continuous and left continuous. In this case, is it? No, it's not. Okay? Mathematically, you would say that the limit as x approaches 0 plus is equal to the limit as x approaches 0 minus of f of x, of course. Okay? Question 15. Okay, the table below shows shows values of a continuous function h given by y is equal to h of x for some selected values of x. Based on the table above, what values of x is h guaranteed to have a root? So over here you have x and y values, and you want to see what intervals would you have a root. Now, what is the rule? The rule is for there exists a root. The symbol is there exists a root if f of x changes sign over an interval, right? So let's take a look here. Where does f of x change its sign? As you can see, f of x basically means y, by the way. As you can see over here, there is some sign changes. So let's take a look at the intervals. We're going to check them one by one. So at -2, at x equals -2, you have a negative value. At -1, you also have a negative value. Since it's both negative, negative, there's no sign change. We're going to x that out. We don't like it. -2, as you can see, it's negative. 0, positive. Is there a sign change? Yes. So is there is root? Yes, there is. Okay, now -1, 0. Same thing we said, -1 is negative. 0 is positive, so a sign change, so therefore it's a root. -2, 2. Same thing, -2 is negative, 2 is positive. So there is a sign change. 0, 1. They're both positive, as you can see here. The y values corresponding to them are both positive. So since there's no sign change, it's going to be no root. 0, 9. 0 here is 2. 9 here is 569. Since they're both positive, there's no sign change, so there's no root. Okay, very easy question. And how many questions do we have? 25? Okay, question 16. Okay, consider the function f whose graph is below. Which of the following statements is true? Continuous, okay, whatever. Let's take a look. The function f is continuous at -pi. So at -pi, they want it to be continuous. That means it should be both left continuous and right continuous. Now, I think it's pretty obvious over here at -pi, it's not continuous, right? So if you, this is an open circle, so we don't count it. To the right, we're approaching 1. Yeah, as you can see, we're approaching 1. We're approaching 1, yeah? And over here, we're approaching what? -1. So they're not the same, so obviously it's not continuous. It's right continuous at -pi. Type. It's right continuous at -pi. Right continuous means what? That the function at -pi should be equal to the limit. Right continuous, that means as x approaches -pi plus, right? Right, that means you're going to the right. So, actually, the first thing you need to check is what is the limit approaching at -pi plus. -pi plus. Here, there's a difference between -pi minus and -pi plus, because as you can see, the graph is changing. At -pi plus, it's approaching what? 1. So it's approaching 1. So what is the value of the function at -pi? Someone's going to come here. He's going to say, oh, perfect. It's also at -1. Perfect. He's going to choose. It's going to be wrong. Why is it wrong, guys? Why? Because it's an open circle. So you ignore this point. Okay, you ignore this point. Okay, the point at -pi is the shaded one down here. Okay, so again, this is wrong because the value at -pi is over here, -1. But the limit as x approaches -pi plus is 1. They're not equal. Okay? F is left continuous at -pi. Left continuous, what does it mean? F of -pi is equal to the limit as x approaches -pi minus. Okay? So let's see. -pi, what's the value of the function? Since it's a shaded circle, we're actually going to take the point. The value of the function is -1. And the limit as x approaches -pi minus, so to the left of -pi, what are we approaching? Also, we're approaching -1. So they're equal. Or you can tell, without any of the rules, I think it's pretty self-explanatory whether something is right or left continuous. Like, look here, مثلا, look at -pi. Is it left continuous? I mean, when you go to the left, is the same point there? Yes. Okay. It's not continuous at -pi. Obviously, since it's only left continuous at not right continuous, and you can see here from the graph, obviously it's not continuous. It goes here, it jumps up to here. يعني أكيد it's not continuous. The graph doesn't continue. F is continuous on -pi. So from -pi to pi, it's continuous. Of course it is. As you can see, يعني مبيني from the graph. Is there any jumps? No. We start here, we go down, up, down. There's no jump. If it was like this and then it went up like this, as you can see, there would be a gap here because we don't have that gap. So obviously it's continuous over the interval -pi. I'm gonna come back and I'm gonna explain exactly this. I was about to explain. I didn't see this point, this choice here, but basically I was gonna explain why it's. Some people are gonna ask questions. Someone's gonna tell me here, Walid, isn't -pi? Isn't it not continuous? Didn't we just say it's not continuous at -pi? How are you saying it's continuous? There's a difference in notations in math between AB and AB like this. Okay, square bracket means included. Parentheses means not included. Okay, so over here when you write parentheses, that means it's the person who wrote it's telling you ignore negative pi and ignore pi, but every value in between them. But when you go and write square brackets, it's telling you including negative pi and including pi. Now pi, okay, it's fine, it's continuous, but we just said that negative pi it's not continuous, so there's no way on earth you can choose this, because if you say negative pi is continuous, if you put square brackets, negative pi will definitely be wrong. If you saw this parentheses and then square bracket, remember parentheses means not included, square bracket means included. If you saw this and they said it's continuous, you would choose it correct. Why would you choose it correct? Because they're telling you, when they put parentheses, that means he's telling you ignore negative pi, and as you can see, if you ignore negative pi, we're ignoring it because we know it's not continuous at negative pi. And then square brackets means count it, yeah, so count pi, and we know pi it's continuous, so if you saw this it would be correct. Okay, also one more thing, now it was in the book, maybe she asks it, maybe she doesn't, is this. You see, it's the reverse. This is the same as parentheses. It basically means opposite of included. So if she were to write it, she would write 1, 2 like this. It's like a reverse square bracket, and that means, you know, not included. Okay, but you never see this. This is very old. Maybe some French books still use it, but they don't use it a lot nowadays. Okay, now what's this? Over which of the following intervals is g of x, which is given to this, continuous? So you need to understand something. If there's a rule here, okay, about continuity, if f of x is a continuous function and g of x is a continuous function, then f of g of x is also continuous. F times g is also continuous. What else? I think you have f plus g is continuous. F minus g is also continuous. And absolute value of f times, or I think absolute value of f minus g is also continuous. Okay, so these are some rules. Also, f of g is also, f over g is also continuous. But comes a rule, except when g equals 0. So cosine x is continuous. Why is it continuous? Because if you draw cosine x, it goes like this, right? And if you continue it back here, it goes like this. Is there any jump? No, it just keeps on going, right? So it's a continuous function. So you have the function up, f of x, which is absolute value cosine x. Okay, and then the function down is just cosine x. So we know absolute value cosine x, why wouldn't it be continuous? خلاص, it's just continuous. But g of x cosine x is also continuous. So like I said here, we have a function where it's a quotient. We're using this rule here. What is the rule? When is it not continuous? When is a quotient not continuous? Obviously, it's not continuous when the denominator equals 0. So when is this not continuous? When cos x equals 0. When does cosine x equal 0? At pi over 2 and 3 pi over 2. Also at negative pi over 2 and negative 3 pi over 2. So if you don't know this, and to do it, how do you do it? You can just go calc, shift cos, just change your calc to radians, 0, and you get pi over 2, right? So what was our rule of cosine? You add 180, and if you're in radians, you add pi, and you get 3 pi over 2. And also, we know that for cosine x is equal to cosine of negative x. So cosine of pi over 2 is also the same as cosine negative pi over 2. And cosine is 3 pi over 2 is the same as cosine negative 3 pi over 2. So anyways, we got our zeros over here. So basically, these are points of discontinuity, right? So anything in between these points will be continuous, but at these points, it will not be continuous. Also, so مثلا, how can I say this? If you were just to draw, okay, we have over here is 0, right? Also, you can say this is 2 pi. Here you have pi over 2. Here you have pi, and here you have 3 pi over 2, right? So over here, from here to here, it's continuous. But over here at pi over 2, you have a 0. And over here at 3 pi over 2, you also have a 0. So also, if they told you from pi over 2 to 3 pi over 2, that would be correct. From pi over 2 to negative pi over 2. What is this? Because you guys know 3 pi over 2 is also the same as negative pi over 2. Because it's just 90 degrees, but in the negative direction. So from here to here, it's also the same thing. Anyways, I'm talking a lot. If you want to do this in your exam very quickly, here's what you do, okay? You can do cosine 0. It's 1. Now cosine pi, you get negative 1. As you can see here, it's whoa. 1 second. Yeah. So you can see here that none of these are 0. You're going to tell me, Tabalid, why is this one wrong? Because from 0, as I drew before, here's 0, here's pi. If you want to go from 0 to pi, you're going to have to pass by this point here. And that point is not continuous. Okay? But here, just so you can see, from minus pi over 2 to pi over 2, it's continuous. Right? Here, Adi, the 0 is fine. Cosine 0 is 1. You know? So here, you pass through them. You can go here, there's nothing you're passing through. Like we said, these are your points. Someone might tell me, Tabalid, you're starting at the point of discontinuity. Doesn't that mean you're going to be discontinuous? No. I told you, since you have parentheses, that means it's telling you don't include that point. That's why this is correct and this is correct. Okay? Basically, just find your zeros, and it goes in between your zeros, if you see this in your exam. Your zeros here are what? Pi by 2, minus pi by 2, and then 3 pi over 2, negative 3 pi over 2. Once you identify your zeros, anything in between them is correct. Okay? Anything in between them. Moving on. If they said, by the way, negative 3 pi over 2 to negative pi over 2, that would also be correct. But they didn't say it here. Okay? Moving on. Question 18. Over which of the following intervals, you have 3 functions here, is this continuous? So again, let's take a look. We have to test out each one. I think it's best here to solve it like the question we solved previously, not the one right before this one. We had one like this before, and they asked us to find which one's the point of discontinuity. I think it would be faster to do that, to see where is your discontinuous point, okay? So how do we do that? We just test out all of our bounds and check, right? So the first thing would be negative 2. That's our first bound to check. Over here, it's always 1. Over here at negative 2, what do you get? Negative 2 plus 1. Negative 2 plus 1 is what? Negative 1, and then negative 1 is just 1. So they're equal, so that means it is continuous at 2. Negative 2. Now let's test out negative 1. Let's see. Negative 1, over here you've got these two. At negative 1, you've got negative 1 plus 1, which is just 0. Okay, and then here you've got 1 over negative 1. As you can see, that's negative 1. So are they the same? No, so it's discontinuous at negative 1. Okay, how about 0? No, you won't count zeros. So over here, it's continuous at negative 2. It stops at negative 1. So if you were to, let's kind of think of a graph. Over here, it's negative 2. It switches. No, actually goes down. It doesn't matter. But it goes to negative 2, switches. It stays continuous, but at negative 1, it jumps. Okay? So this is how the graph looks. So over which of the intervals is it continuous? Let's say you don't have the graph. We just know, we just figured this out. That is discontinuous at negative 1. How do you do this? Negative 3, 0. From negative 3 to 0. Does it pass by any discontinuity point? Yes, it does. So can you say it's continuous? No. Negative 2, 0. Same thing. It passes through negative 1. So can you say it's continuous? No. Negative 1, 0. Someone's going to tell me, what do you eat? Negative 1 is discontinuous. How is this correct? Man, like I told you. Parentheses, what does it mean? It means don't include it, leave it out. Okay, negative 1 to 0, we're leaving out the point of discontinuity. Everything onwards after negative 1, you're going to count that. That's why it's correct, right? So you skip the discontinuity point, the point of discontinuity. Again here, negative 3 to negative 1. Are you passing through any point of discontinuity? No, we're not. Our point of discontinuity is at negative 1. and we have a parenthesis on that, so it's not included. -2, -0.5. Over here, you are passing through -1. It's somewhere in between. So therefore, sorry, this is correct. So therefore, here you're passing through a point of discontinuity, so you can't say it's continuous. Okay. Question 19. Recording ما بده يخلص. Over which of the following intervals is f continuous? As you can see here, we have our graph, and you have some points where it is open circles, so they are undefined at that point. Anyways, over here it's good to note that at 0 you have an asymptote. I think you can kind of see it. The function is not reaching x equals 0. So this is an asymptote here. So you can, in case, I'll show you. So from -1 to 1, is it continuous? So from -1, you're over here. You go down, and then you jump up to here. So is that continuous? No, it's not, right? So the first one is wrong. From 0 until 2, so from 0, so 0 onwards, right? Someone's gonna tell me, what do you said 0 is undefined, how are you counting it? It has parentheses, right? So you can't, you're not counting it, you're skipping the 0 and you're going onwards. Someone's gonna tell me, طب وليد, over here at 0.00001, there's a small gap over here. طب يخيي, it's not drawn perfectly, you know. This is just to show you, the small gap is there just to show you that 0 is an asymptote. Okay, so anyway, 0 onwards, going to 2, as you can see here. Someone's going to tell me also, well, it's undefined here, how can you say it's continuous? Well, like I said, it's an open circle, so you're not counting this point. Okay, sorry, it's parentheses, so you're not counting the open circle. So everything in between, so before this open circle and after this gap here, is it continuous? Yes, it is. Okay, -1, 0, from -1 to 0. Again, -1 and 0 are not counted. Why? Because it's in parentheses. So everything after this -1, so over here, and everything before this gap here, is it continuous? Yes, it is. Okay, that's nice. Between 0 and 3, obviously it's pretty obvious. From 0 onwards to 3. 3 is over here. As you can see, there is a jump here. So that's wrong. From -1 till 2, this is pretty obvious, yani. From -1 till 2, over here, -1, you come down here, and then what? You jump up to here. How is that going to work? It's not going to work. All right. Moving on. Question 20. What is true about here? Ya Allah, man, I hate this chapter so much. But it's very fundamental. Sorry. It's very important that you know this for math. It's one of the most important chapters moving into uni math and moving into grade 12 math. You need to know limits and continuity. Because it teaches you a lot, especially continuity. It's used not only in engineering, it's used حتى in medicine. It's used in almost every major in the world. You're going to have to look at graphs, and your knowledge of whether it's continuous or not will be very helpful in analyzing whatever graph you draw, حتى in chemistry and physics. This chapter is extremely important. Anyways, which of the following is true about x cubed plus 1 over x squared, about its continuity? So, as you can see here, we have a denominator. And what did we know about when we have two functions over each other and the limits? We know that if the one up is continuous and the one down is continuous, then it will all be continuous except at the point when the denominator equals 0, right? When does x squared equal 0? At x equals 0, right? So, it's going to be continuous at every point except x equals 0. So is it continuous at x equals? Obviously not. Is it continuous at x equals -1? Yes. No reason for it not to be continuous. It's discontinuous at x equals 0, like we said. Since that makes the denominator 0, then it's going to be discontinuous. It has a removable discontinuity, jump discontinuity, infinite discontinuity. No. Why? Because the graph over here looks like... How can I say this? The graph looks like... Let's just say it looks something like this. At x equals 0, you have -1, you have what? -1 plus 1, 0. Over here. So, طيب, you have, it's going up. Like this. You have the graph kind of looks like this. Okay. Now, you're going to tell me, Walid, why did you draw through the open circle? When graphing, you just put the open, you graph it and then put an open circle on the point where it doesn't exist. So we know that at x equals 0, there is no point here, right? There's no point. It doesn't exist, right? It's undefined. Now, the graph looks like this, and it looks like it's normal, but we have that open circle that tells us it's undefined at x equals 0. So what type of discontinuity is it? Is it a jump discontinuity? The jump discontinuity actually looks like this. It jumped, okay, hence the name. A removable discontinuity, I think I'm not gonna say it. I'm gonna search it up and show you, because I'm not 100% sure. I don't want to say something wrong. Okay, yeah. See, this is what happens when I try to act smart. Let me just erase this. Okay, so the function over here at x equals 0, how can I say this? We have a point here, it goes like this. This is how our function looks. Something like this. Okay, I don't know, I'm not so sure, but something to do with this. But what's my point here? When you graph it, it looks like this. You want to know if it's an infinite discontinuity, removable discontinuity, jump discontinuity. Jump, I showed you what it looks like. Removable is what I drew. What I drew previously was removable. When you have the graph and then you just have an open circle, that's what removable is. Infinite discontinuity is what we have in this case, and it's when it tends to a number, but it doesn't reach it. So that's what we call an infinite discontinuity. Now in the exam, who is going to graph? Nobody's going to graph, right? So you're going to tell me, Waleed, bro, I ain't doing all that in the exam, right? You're not going to do all this. But what are you going to do? How are you going to figure it out? If it's an asymptote, simply, if it's an asymptote, then it's going to be an infinite discontinuity. When you have these rational functions, x squared, whatever, f over g, when g equals 0 is at a point of discontinuity, and it is a vertical asymptote, right? When the denominator equals 0, and therefore you say it's an infinite discontinuity. Okay? Discontinuity. Question 21. For what value of k is f of x equals 3 minus kx, and then x squared minus x plus k continuous at x equals -2? Remember, for it to be continuous, that means the left limit must be equal to the right limit. So what is the limit for -2 minus, and what is the limit for -2 plus? They should be equal, right? As x approaches this and as x approaches this, the limits should be equal. Now let's take a look. At -2 minus, yeah, sorry, why did I completely blanked. Yeah, -2 minus, that means we substitute -2 into the function and see what the limit is. But which one do we substitute -2 into? Obviously, since we're looking at -2 minus, we're going from the left of it. So we're going to look at this one, right? So 3 minus k into x, which is -2, which is 3 plus 2k. Now, as 2 plus, that means to the right. So we're going to substitute it into this. So -2 squared minus -2 plus k, which is 4 plus 4 plus k, so 8 plus k. So you've got these two, and these are our limits. Now we know that they should be what? Equal, right? So when it's continuous, what you should do is find your limits for each one and equate them simply. Okay, so you're going to get that k is equal to 5. What? What is it? 3. Take k here. 3 minus... This is 3 plus 2k. And then here you have -2 squared, which is 4, minus 6. Sorry, this is plus 2. How did I get 8? Yeah, so -2 plus 2. Sorry, 4 plus 2 is 6. Okay, so you should get k is equal to 3. Yeah, absolutely. Absolutely. Yeah, this is 3. Question 22. Okay, you have two functions again. For what value of k is it continuous at x equals 1? Same thing. What did we say for it to be continuous? That the left-hand limit must be equal to the right-hand limit. So over here, 1 minus. So you could take a look at anything, yani. But basically means the limit here should be equal to the limit here. So let's take a look at 1. Let's substitute 1 here. 1 squared minus 1 over sine 1 minus 1. Well, you have 0, which is indeterminate form, right? Now, what do we do when we have 0 over 0? Do we just say, خلاص, 999, ويعطيك العافية? No. we have to actually find the limit, right? So what we're going to do, we're going to do L'Hopital. So let's derive the numerator. X squared minus 1, what does it become? It becomes 2x. And then sine x minus 1, what does it become? It becomes cosine x minus 1 times the derivative of what's inside, which is just 1, which you don't have to write. Okay, so your new function is 2x over cos x minus 1. Substituting your limit 1, so 2 times 1, over cosine 1 minus 1, which is just equal to 2. So your limit is 2 for the first function. Now for the second function, at x equals 1, since k is a constant, limit of any constant k, what is it equal to as x approaches 1? As x approaches any number, it's just going to be k. So that means we have to equate both limits. That means 1 minus, which we found to be 2, is equal to 1 plus, which we found to be is what? K. So the value of k is simply 2. Question 23. You have same thing, two functions, piecewise. Which of the following is true about g at x equals 2? So we need to know whether it's discontinuous or continuous. Okay, and how do we check that? We check that, by just checking the limits of the left hand and right hand and check whether they're equal. So let's check the left-handed limit. Limit of 2 minus and limit of 2 plus. Are they equal? Question mark. Okay, 2 minus, we're going to take 2 cubed minus 1, which is 7. And then 2 plus, it's just going to be 3 times 2, which is 6. As you can see, it's not equal, right? They're not equal. So over here, it's going to be discontinuous. Now, are we going to know, is it removable or jump discontinuity? The first thing is, it's obviously not, now it's not written in the choices, it's not an infinite discontinuity. Why is it not an infinite discontinuity? It's not an infinite discontinuity because you don't have any denominator here, there's no asymptotes, okay? You only have a infinite discontinuity if the function tends to infinity, and that's when you have an asymptote, but we don't. So is it a removable continuity or a jump continuity? A discontinuity, sorry. How do we know? Now, as you can see here, your value jumped from 6 to 7. That means it's a jump discontinuity. Now, someone's going to tell me, Walid, how do you know if it's a removable discontinuity? It's a removable discontinuity if the function is undefined. You know, I'm kind of going to make like a small table. It's infinite discontinuity when it tends to infinity. In other words, there's an asymptote. Okay? It's a removable discontinuity. No, let's do jump. Jump discontinuity when f of x, or sorry, when limit of x approaches a minus is equal to limit, sorry, is not equal to limit as x approaches a plus, and the function is defined. Okay, now the removable discontinuity the function has to be, function is undefined at that point. Okay, so over here we need to check whether or not our function is defined or undefined at our point x equals 2. Now, how do I check whether it's undefined? I need to check what is the value of the function at 2. And how do we do this? What did I tell you? You have to substitute 2 into one of your functions. Now, which one do we do it? Do we do it in this one? We don't do it in the first one. No. Why? Because here the domain is all values strictly less than 2. We want to be equal to 2. So to be equal to 2, we're going to choose this domain, and it's x greater than or equal to 2. That's the domain they wrote here. So we're going to choose that. Okay? So substituting 2 into here, 3 into 2, which is 6, and as you can see here, you get a number, so it's not undefined, it's completely defined. So is it going to be removable? No. It's going to be a jump discontinuity. Okay, question 24. 2 more questions and we're done. Consider the function whose graph is shown below. Let's take a look. F is not continuous at x equals 0 because it is not defined there. So over here at x equals 0, as you can see here, it's an open circle. Maybe you might have to zoom in to see that. But it's an open circle, so obviously it's not defined. There's no shaded circle to make up for it. It's strictly not defined there. Okay? F is not continuous at x equals 0 because the limit as x approaches 0 minus is not equal to 0 plus. As you can see here, it's equal. To the left of 0, it's approaching what y value? 0. And to the right of 0, what y value is it approaching? It's also approaching 0. But the only thing that makes it discontinuous is what? It's not defined there. So what type, if they asked you, what type of discontinuity would this be? This would be a removable discontinuity. Why would it be removable? Because it's undefined at that point. Type. We did these. Third one, f is not continuous at x equals 1 because the limit as x approaches 1 minus is not equal to the limit as x approaches 1 plus. Now let's take a look. At 1 minus and 1 plus, as you can see here, the limits are not equal. Okay, you don't have to check. It's obvious. It jumps. Okay. If they asked you what type of discontinuity is this, you would say it's a jump discontinuity. Why? Because here it jumped. Okay. Also, why isn't it undefined? Why isn't it removable? Someone's going to tell me, oh, you have this open circle. Why isn't it removable? Because it's not undefined. Okay, there's an open circle, but like I told you so many times in this video, if it has a shaded circle to make up for it, then it's not undefined. Type f is not continuous at x equals 1 because it's not defined there. Is that why it's not is that the reason why it's not continuous? No, we said it's not continuous because the limits don't approach each other. You know, binding. Okay. F is not continuous at x equals -1. We said, by the way, it's defined there, huh? As you can see, it's defined at 1. It has a shaded circle. F is not continuous at x equals -1. Let's take a look. At x equals -1, why would it not be continuous? You don't have any value that makes it undefined. There's no open circles here, so it's not undefined. Well, as you can see here, to the left of -1, it's approaching 1, and to the right of -1, it's also approaching 1. So there's no reason for it to be discontinuous. There's no jumping, there's no undefined, there's no asymptote. Question 25, last question. Which of the following? We have a nice graph here. Okay, so as you can see here, we have a graph, and you may not see it, but there is a shaded circle right here to make up for this open circle. Okay, so let's take a look. F is continuous at x equals 0. Is that true? At x equals 0, it's continuous. Yes, obviously, it's a straight line, no asymptotes, no open circles, no jumping. Very easy. F is continuous at x equals -1. At -1, is it continuous? As you can see, the limits approach the same value. Yeah, so the limits approach the same value. But at this point here, at the point of -1, the value of the function does not equal the limit, right? The value of the function over here jumped to 0. This is 0, right? It jumped to 0. So is it continuous? No. Since you have this open circle and the shaded circle way above it, that means it is not continuous. There's no reason it would be continuous. Type. F is not continuous at x equals -1 because the limits don't equal each other. No, I just told you that the limits, they equal each other. As you can see, both parts of the graph are tending towards the same value. So that's not the reason. F is not continuous at x equals -1 because it's not defined there. Many people I know will definitely choose this, but that's not the reason. Why? Because it is defined. It has a shaded circle. It is defined. But it's not continuous because, like I told you, the limit, yeah. Okay, well, when I get there. Okay, let me just go to the next point. F is not continuous at x equals -1 because the limit does not exist. Why would it not exist? Why would it not exist? We said for a limit to exist, the limit as it approach a minus, let's for any value a, should be equal to the limit as it approaches a plus. And as you can see here, it is equal. To the left, it's equal. It's approaching the same value. To the right, it's also approaching that same value. So it is there. Okay? But what is the reason for it not existing? Hello, we reached that choice. Why doesn't it exist? Like I told you, because the value of the limit, what is the value of the limit? I think it's -1, right? The value of the limit is not the same as the value of the function at that x point, -1, right? They're not the same, okay? This is what we call a jump discontinuity, because at the point it jumped, okay? So this is the reason, because the limit is not the same as the value of the function at -1. That being said, thank you so much for watching, and good luck in your exam.